Hello dear students. In today's class we are going to discuss about the difference between distance and displacement, difference between speed and velocity, difference between instantaneous speed and velocity. Also at the end of the lesson you will be able to distinguish average speed and velocity, and at the end the difference between distance time graph and displacement time graph. Okay, yes, shall we go now? You already know rabbit tortoise race story. Okay, so in a forest race, the rabbit quickly zoomed ahead, reaching 40 meters, but then took a nap. The tortoise, though slower, kept moving steadily without stopping. By the time that the rabbit woke up, the tortoise has crossed the 80-meter finish line and won the race. Okay, so in this story, what is the total length of the path covered by the rabbit and tortoise? Here I mentioned, you can see in the image, the rabbit rest at 40 meter and the tortoise won race at 80 meter. So what is the total length of the path covered by the rabbit? Yes, it is 40 meter. What is the length of the path covered by the tortoise? It is 80 meter. So what is this? What is this total length of the path in physics? Yes, it is distance. Distance is the total length of the path traveled by an object regardless of direction, and it has only magnitude. That means it has only a value, no direction. It will be always positive and never decreases. Another example, if you walk 3 kilometers from home to school, your distance traveled is 3 kilometers. Okay. Similar term is displacement, but it has a difference. What is it? It is the shortest straight line distance from the initial position to the final position. Okay. So here we are mentioning its magnitude as well as direction. Okay, so I have a question for you. If the tortoise returns back to the starting point, what is the displacement? First is start from 0, then end up at 80 meter, then he return back to initial position. What is its displacement? It's 0. Okay, so I think you understood the difference between distance and displacement. Next is speed and velocity. Speed is nothing but the rate at which distance travel changes with time, or we can say distance covered every second, that is speed. Velocity is nothing but the rate at which displacement changes with time. And speed, we are mentioning only the magnitude, so it is a scalar quantity. For velocity, we are mentioning both magnitude as well as direction, so it is a vector quantity. So we can say the examples. First, for speed, a car is moving on a highway at 60 km per hour. This tells us how fast the car is traveling but does not specify the direction. Okay, so similarly for velocity, a car A car is moving east at 60 km per hour. Since it includes both magnitude and direction, this represents velocity. Okay, so what's the equation for speed? Speed is nothing but distance traveled by time taken to travel. So what's the equation for velocity? Change of displacement by time taken. Okay, that is delta S by delta T. I think you understood the difference between speed and velocity. Speed is nothing but distance covered in every second. Velocity is nothing but displacement by time. That is rate of change of displacement. Speed is rate of change of distance. Okay. So similarly, distance is the total path length and displacement is the shortest straight line path covered by an object in a particular direction. Okay. So next is instantaneous speed and instantaneous velocity. Instantaneous speed is the speed of an object at a specific moment in time. For example, if you are traveling in a car, the traffic camera records the speed at a particular instant, isn't it? So we can say, or another example, a car speedometer reads 50 km per hour at an instant. That means specific moment, the speed at specific moment. Okay. What about instantaneous velocity? The velocity of an object at a specific moment in time, including the direction. A car is moving 50 km per hour east at that instant. Okay. So now the next is average speed. What is average speed? Total distance traveled divided by total time. If a car travels 100 km in 2 hours, so what will be the average speed? 100 divided by 2, that is 50 km. So another example, if a car travels 100 km in 2 hours and 50 kilometers in 1 hour. So what will be the average speed? 100 plus 50 by total time. What is the total time? 2 plus 1, that is 3. Okay, so here 150 divided by 3. What is 150 divided by 3? That is 50 kilometer per hour. Okay, so next is average velocity. Total, what is average velocity? Total displacement divided by total time taken. A car travels 50 kilometer east and then 50 kilometer west in 2 hours. So here change is 50 minus 50, 0. So average velocity 0 kilometer per hour. Understood? Okay. Now the next is very important, that is distance time graph and displacement time graph. Distance time graph is in x-axis we plot time and y-axis we plot distance, and whereas displacement time graph in x-axis we plot time and in y-axis we plot displacement. Very important thing, there is a term gradient. Gradient of any graph gives the rate of change of the y-axis. Rate of change of y-axis with the x quantity. Okay, now look at the distance time graph. What is the gradient here? Rate of change of the y-axis. What is in the y-axis? That is distance, change in distance by the change in x-axis quantity. What is in the x-axis? That is time taken. So change in distance by change in time. So the gradient of distance time graph is speed. Now what about displacement time graph? Gradient will give velocity. Understood?